This video will be about continuity and its consequences. So the first thing we're going to do is get a kind of intuitive understanding of what continuity is. So if we have a graph, let's say it looks something like this, then you could say that it's continuous because it doesn't stop. But if we have a graph that has a hole in it, so that would be something, say, where you have a line, a hole at one point, and it continues, then that would be a discontinuity. Or if you have a vertical asymptote, that would also be a discontinuity. Or say if you have a jump from one point to another. Which would be something like this. Then in these three cases, we have functions that are not continuous. Now we can give a formal definition for continuity. A function f of x is continuous at a if 1. F of a has to be defined. 2. The limit as x approaches a of f of x must exist. And finally, the limit at that point has to equal the actual value at that point. Now we can go back to our graphs and explain, with the formal definition of continuity, why they're not continuous. So if we recall our hole, the reason this is not continuous at a is because f of a is not defined. Now for our vertical asymptote, where we had a graph something like this, the reason this is not continuous is because the limit does not exist. And finally, for our example with the jump, we have that the function is defined. However, the limit does not exist at that point. Now we can look at one more example where we have a function where the limit exists and the function is defined at that point, but we have still a discontinuity because the limit does not equal the value of the function. So some of the examples of discontinuities that we've looked at are removable, while others are non-removable. It kind of makes sense to think that the hole is a removable discontinuity because for the most part the function still looks pretty smooth. And same with the example where we had a point randomly outside of the function. Non-removable continuities are things like the vertical asymptote because the function goes completely crazy at that point and it's really not smooth at all. Similarly, a jump is not removable because the function in general isn't really smooth. Now, for a more formal definition of removability, we say that a discontinuity is removable I'm going to use some abbreviations here. If the limit at that point must exist, first of all, let's say that if the limit equals L, then we can define a new function, g of x. We'll say g of x will equal f of x most of the time for x not equal to a, and then it'll equal L when x does equal a. If this new function is continuous, then our discontinuity at a is removable. Now for some even more terminology. We say that a function f of x is continuous on the open interval a to b, which we represent with parentheses, if f of x is continuous for every point between a and b. So, continuous between a and b. Similarly, we say that a function is continuous on a closed interval a to b. We represent that with square brackets. If, first of all, it must also be continuous between a and b, and the limit approaching a from the right has to equal the value of the function at that point. And same with b, approaching that from the left, it has to equal the value at f of b. One consequence of continuity is something called the intermediate value theorem. So this says that if a function is continuous on the open interval a to b, then if we have a number n that is between f of a and f of b, there must exist a number c between a and b such that the value of the function at that point equals n. Now that might sound pretty complicated, but really all it's saying is that if you have a continuous function from a to b, let's just imagine that f of a is down here and f of b is up here, then there's no way you can draw the function so that it doesn't go through some of the points between f of a and f of b. So let's imagine that I'm interested in this point that's between f of a and f of b. There's no way I can possibly draw the function so that it never reaches this value at some point. Right, so if I'm going to make it continuous, then at some point it's going to have to cross this value. The only way I can make it not cross is if it's discontinuous. So if, say, I went like this, and then all of a sudden I had a big jump over here, in that case, I didn't cross this value because the function is discontinuous.